If the coefficients of tr, tr plus 1, tr plus 2 terms of 1 plus x to the power 14 are in AP, then what is the value of r? The rule is, if tr plus 1, tr plus 2 are the terms of 1 plus x to the power n, and the terms are in AP, then r equal to n plus minus root upon n plus 2 by 2. Now comparing with this sum, we can write r equal to n, that means 14. 14 plus minus root upon 14 plus 2 by 2, that is 14 plus minus root upon 16 by 2, that means 14 plus minus 4 by 2, that is 14 plus 4 by 2, that is 18 by 2, that is 9, or 14 minus 4 by 2, that is 10 by 2, that is 5. So value of r may be 9 or 5. So among the four options, D is the right answer. If the coefficients of rth, r plus 1th and r plus 2th terms in 1 plus x to the power m are in AP, then which of the following four relations is true? We should apply the same rule as before, that is, if rth and r plus 1th and r plus 2th terms of 1 plus x whole to the power m are in AP, we can write r equal to m plus minus root upon m plus 2 upon 2. Now this implies that 2r equal to m plus minus root upon m plus 2. Now we can write 2r minus m equal to plus minus root upon m plus 2. Now squaring both sides, 2r minus m square equal to m plus 2. Now 4r square minus 4 into r plus m square equal to m plus 2, which implies that m square minus, we can take common m into 4r plus 1 plus 4r square minus 2 equal to 0. That is, C is the right answer. If in the expansion 1 plus y whole to the power n, the coefficients of 5th, 6th and 7th terms are in AP, then what is the value of n? 5th, 6th and 7th, that is rth and r plus 1th and r plus 2th. So the value of r obviously equal to 5. So 5 equal to n plus minus root upon n plus 2 upon 2. Now solve it. 10 minus n equal to plus minus root upon n plus 2. 100 minus 20n plus n square equal to n plus 2 implies that n square minus 21n plus 98 equal to 0. So value of n equal to either 7 or 14. So B is the right answer.